let's get going here. So these are the things that I want to cover. Ray talked to you kind of about that, and so we're going to start in your packet on page. Oh wait, yeah, on page 16. Okay, and here we go. By the way, let's kind of remember we're backwards on our schedule today. We do get out of here at 12:26. Okay, so we'll keep in mind on that. All right, so here we go. On page 16, we're talking about outliers, leverage, and are they influential? And I know that you know any point that's out of the way of the others is an outlier. Okay, next slide. This is a picture of votes that happened and such on in the 2000 presidential election. So there obviously was an outlier. Okay, and one of the things I want to talk to you about outliers is that you actually need to look at them and do not just necessarily discard them, because if you have an outlier that's that different from all the other counties on how they voted, you might want to look at why that is, what happened. And does anybody remember what actually happened in that 2000 presidential election? Perfect. Yes, absolutely. All of that stuff. Yeah, they did recounts. They were finding that there was an error with the way that they bubbled the little sheet, or they coded it or stamped it or whatever, and it like they had like Chad was a word, I don't know, partly done. But yeah, they were wanting to recount them by hand and everything. I mean, how accurate was that going to be? And so it was a big old deal. So you want to look at that outlier. You shouldn't just say, oh, there's an outlier, discard it. No, you need to look and see what the heck's happening there. Okay, now let's talk about, you know, in this case, we had an outlier that really would change this equation of the line that best fits. So you can see that this blue line here, okay, this blue line is what it would be without that outlier in there. When they put that outlier in there, then you had this line. So what did it do to the slope? So one of the things I want to talk about is how did things change? How did that slope change? It increased. It got steeper. Okay, so that's the kind of language that you would want to see, is that the slope increased. It got steeper. All right. Next. I think we'll skip that page. Okay, so here we now have the topic of leverage. Okay, so the definition of leverage: something has got high leverage if it is far out, man, far out in the X direction. Okay, you can see this picture. It's a little difficult to see, but you can see, you know, here is where the data is. You know, it's all in this section. This out here has high leverage. If you can imagine, this guy is very easily going to move this data because of this high leverage that he has. He is far out in the X direction. He's way far out because most of the data values are down here. Okay? So high leverage means you are far out in the X direction. So keep that in mind. Frequently, these ones that have high leverage are influential. They actually don't have to be, and we'll go over that today. But here's the definition of influential. If you take that point away and it significantly impacts the equation of the line, then that is considered influential. All right, so we've kind of gone two definitions. I like to talk about this here, and I think actually I'm going to show you some. Let's go jump to some digital stuff. Let me get to my link and get us out on the internet. Let's see here. Okay, let's check this one out here. Oh, I think. I need to get to Internet Explorer because it doesn't do it properly through Rome or something, or whatever that was. Okay. Okay, very good. Here we go. Okay, so first thing I want to talk about. Hey, let's think about a problem where I talk about your IQ and your shoe size. What do you think about your IQ and your shoe size? Do you think there's some kind of relationship there between your IQ and shoe size? Okay. If there is, it's very weak. So you think that your shoe size and your IQ probably don't have much of a correlation. So I want you to look up here at the top. This thing demonstrates it will give you automatically the R value. Here, it's an R value of negative zero point 0.1. What would you say an R value of negative zero point 0.1 is? Very weak negative. Good. Very slightly, very weak negative. Okay. All right. Okay, so it's not very well correlated with the data. Nice. Okay, but what if I tell you that we have Bozo the Clown, and you know Bozo the Clown, he's got huge feet. So his feet are massive. So let's just say, here we go. Here's Bozo the Clown. I'm going to pull this out here because his feet are insanely huge. Okay. We still don't have much of a correlation. You see the correlation is pretty much zero still. But what if I say, you know what, strangely enough, he is just a freaking genius. You thought he was dumb, but no. Bozo the Clown is an insane genius. Look at this. So what's happening is, look at the correlation now. What is it? It's strong positive. Yes. So what I want you to get from this is that um, one point could be so influential that it takes something that is not supposed to have any correlation whatsoever, and it makes it look like it has a strong correlation. Okay? Let's even think about residuals. Let's talk about residuals. What kind of residual would you have here? You'd have a positive residual. Is this positive residual very big compared to even say like this residual? Does this have a very big residual? Not really. So let me tell you something. This point is so strong that it did some things. It made it look like there is a correlation when there really is not. It made it look correlated when it is really not correlated. Furthermore, it wasn't even a big residual. It pulled the line to it. It was so strong and pulled the line to it. It had a small residual. It had a small residual, compared to some of these other ones. Okay? So that is just weird because we know IQ and shoe size are not supposed to be correlated. They are supposed to be, pretty much just, nothing going on. See right there? Nothing going on. Zero correlation. Okay. All right. So there's some things that I'm interested in talking about that happen. Okay, back to our little slideshow. So here's kind of what those examples are here. If we had shoe size and IQ, you can see that. First picture, you got Bozo the Clown. He's way smart. Second picture, you got Bozo the Clown. He's way dumb, not smart. And so you can tell that he was so influential, he pulled the line wherever he was. Okay? Whether if he was really smart, he pulled it up. If he was not smart, he pulled it down. Okay? Yep. All right, so next. Let's see here. Are we just about done with our slides? I think, oh, here's a warning on this slide, and I actually just talked to you guys about it. I said influential points can hide in the residuals. If you had that, remember Bozo the Clown? He was really influential, but did he have much of a residual? Bozo the Clown, very influential, but he did not have much of a residual. So do be careful with that. Let me pull him out here, show you one more time. Okay, warning, you could be very influential and your residual might not even be as big as some of the other data points over here. Okay, so that's something to be mindful of. Okay, points that have high leverage have the potential to be very influential. They may not actually be posing that, and I'll show you some of those. All right, very good. So you have this page, but you also have, is this page what's next in your packet? Okay, we have this page 17 in your packet. And what I want to do now is kind of see if you can draw the lines of what the added point is doing to the line. So you have two different colors. You have a you can do dashed, or you can do, here I had told you to do dashed and solid, but since you have two colors, you can just use your two colors. So I want to first pick a color. You pick a color. I'm going to use blue, and I'm going to draw a picture of what the line would look like with if that unusual point is not in there. Okay? So I want you to do that right now. Draw a line where you think that line would be if that unusual point is not in there. Does that line make sense? Okay? Yes. Now, I want you to consider that point in there. What do you think that's going to do to that line of best fits? Now, with a different color, let's draw another line. What do you think that's going to do? I don't know. We'll talk about the correlation in a minute. I just want to know, what does the line do? Yeah, I think that this point right here is going to pull this line towards it. It's probably going to kind of do that kind of thing, right? It's going to tilt it a little bit, pull it a little bit towards it. Okay, so I'm going to draw that where it kind of is going to tilt it a little bit and pull it towards it. Okay, just to kind of prove it to you, let's draw something that looks like. Actually, why don't you put some of those other ones, do the other ones while I get this one set up for you. See if you can guess how the other ones change. Okay. Okay, so let's see how this worked. Let's also look and see what happens to our correlation. With everything all nice and tacked, the correlation is 0.79. What do you have to say about that correlation? It's good. Good. Strong and positive. But let's see what happens in like number 1. Okay? I'm gonna take one of them out of whack and pull it up here. So this one had a correlation that was strong and positive. Let's see what this does to that correlation. Okay, so here it goes. I'm going to pull that thing. Oh, dang. Okay, sorry. Got to use it with my mouse. Here it goes. I'm pulling that thing out of whack. Interestingly enough, did it actually change that line too much? Interesting. This is interesting. Let me see. There we go. Okay. So it kind of pulled that line up a little bit. How about the correlation now? When that's an outlier, what's the correlation? Yeah, it went to 0.58. So it changed it from a strong correlation to a negative or a moderate correlation. Correlation went down. It went down because now it's not nicely correlated around the points. It's not all nice and tight. It's not nice and tight around the line. It's kind of got one point throwing it off whack. Okay? If you were to say what happened to the slope, what did this point do to the slope? It increased it. It made it steeper. It increased it. All right. Those are the two main things I'm interested in when you have an outlier. Okay, very good. Let's do the next one. All right, let's see how this one works. Oh, I forgot to talk about something I wanted to mention. Number one, this point would not really be having high leverage. Let's talk about this. We haven't really talked much about that word leverage, but we need to. This is not got high leverage because what is the definition of leverage? Far out in the X direction. Is that thing far away from the data left and right? Okay, and that answer is no. So see, all right, next. Where'd you draw this line? Does it look like that without the point? And then what'd your point do? Did you pull it down a little bit? Okay. Now, here's my other question. Does this point have high leverage? It does not. So this is also not high leverage. It really is kind of difficult for this thing to be very influential if it doesn't have high leverage, but we'll talk about that. So, hey, how about I go draw it over here and let's see if we can see what it does. What do you think it will do? What do you think that point will do? What do you think that point will do to the correlation? Okay, well, let's look and see. Let's see. Is this what the points, the original points look like? Something kind of like that? All right, something kind of like that. Okay. Maybe I could do some kind of dual screen here. Nope, not going to work. Okay, so they look kind of something like that. What kind of correlation do I show? Original correlation is what? Yeah, negative 0.88. So that's nice and tight and strong. Okay, so now let's put some point out of whack. Let me get one of those points out of whack. What do you think is going to happen to the correlation? Good. It will go down because I'm going to put a point out of whack. You ready? Watch this R value up here up top. Here it goes. Boom. Look at what happened. Okay? The correlation went down because that one threw off the nice tight cluster around the line. Okay? By the way, let's see if we can see what happens to the equation of the line. There's the original line. Here is the line with that point in it. Okay? So let me show you that again. See, here's the original stuff. Okay? And then here is what that point is when it goes out of whack. All right. Very good. Moving on. So here we go. We got this one. There's our stuff. What's this point over here? Here's our outlier. Here's our unusual point. What's that going to do? It's going to kind of pull this line down some. Yeah, I didn't like how I did that. Kind of pull it down a little bit. Okay. What does that do to the slope? How's that going to change the slope? The slope goes less steep. That unusual point makes the slope less steep. What will that unusual point do to the correlation? Yes, it's out of whack. So since it is out of whack, the correlation goes down and gets weaker. Okay, do you see that? An out of whack point makes the correlation weaker. I think that makes common sense. Okay. All right. So we're kind of getting the picture on those. And same thing with 3 and 6. Now let's look at 6. 6 is a bit more interesting. 6 is more interesting. We're going to look at 5 and 6. 5 has definitely got something worth talking about on it, and we'll do that here in a second. 5, we got this going on. Let me ask you about the leverage of this point here. It's pretty far out in the X direction because most of the data points are centered over here. So if that's pretty far out in the X direction, then what am I saying about it? It has got high leverage. Let me tell you something, people. A point that has high leverage very easily changes the equation of the line. Okay, listen. A point that has high leverage very easily changes the equation of the line. These ones that didn't have high leverage, it actually takes a lot more effort. They don't really change the equation of the line so much. But this one, being out here, is going to really toggle this line and move it. It may even move it so much it might even turn into a negative slope or something. But those ones that have high leverage are very much more potential to impact that equation of the line, changing the slope, and of course changing the correlation. So tell me, without even going to the computer, this influential point being down here and being out of whack, what will that do to the correlation, the linear correlation? It will make it weaker. This is out of whack. If you have an out of whack point, it will make the correlation weaker. Okay, now here's one worth talking about. Your point, what's interesting about these? First question, do they have low leverage or high leverage? They have high leverage because they are far out in the x direction. They have the potential to be very influential. And the definition of influential is changing that equation of the line. So they have the potential to be very influential, but here's my question. Is that point acting upon its ability to be influential? Is it actually exuding that influence? Exhibiting influence? Perfect. Because it's along the same line, it is not being influential. Okay? So it is not influential because the definition of influential means changing the equation of the line. It has high leverage, but because it's all nice and tidy in the line still, it is not changing the equation of the line. Okay? How about the slope? How's the slope changing with this problem? It's not. The slope is going to be about the same. Here is the one. Here's something. Okay, listen up. Here's the thing that is not going to be intuitive. This is going to seem a little unnatural to you. I want to talk to you and I want to show you a thing on the computer about what happens to the correlation when you have a point out there that is in line. So let me come over here to our little app. Okay, so let me get this set up here. What is it? We got stuff going on. Got kind of a positive slope. Everything's fairly correlated. Okay. All right, there we go. Got ourselves kind of that going on. Okay, nice. Now, here's the thing that I want to point out to you. Okay, for the explanation of this, I want to talk about the x values that this one follows, or the domain for which where these points fall. Okay, so the first question is, can you read from this graph up here? I know it's kind of hard. What x values do these pretty much go from? Very good. It looks like these x values are going pretty much from 12 to 18. Okay, so if you remember from how you would do this in Algebra 2 and such, your domain is going from 12 to 18. All right, somewhere along those lines. Okay. Now, so the original domain is just going from 12 to 18. And the correlation when our domain was from 12 to 18 is 0.92, which is nice. It's a nice, strong, positive correlation, right? Okay. All right, guys, watch this. I'm going to take a point. I'm going to move it far out there, but I'm going to keep it in line with the rest of the data, okay? Let's see what happens. Here it goes. What happened to the correlation? It got bigger. It went to 0.99. So let's talk about why. I need you, that's not intuitive. That doesn't necessarily make sense in your brain because you're like, oh, it's an outlier, so it should make it go down. But no, because 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 this point is still in line with the original data, let's look at the domain for which this line now is valid. We're still going from about 12, but what's the top of my domain? Yeah, so the domain is, it's saying, hey, guess what, people? This line is good not only from 12 to 18, but this line is good from 12 to like 30. So this line is valid for a longer distance of time, so it's a much more strongly correlated line. That's why the correlation goes up. Okay, so that's why it's like you've got another point further out here in line, and it's saying, hey, you're a good line. You're a good line, not only from 12 to 18, but 12 all the way out to 30. So good job. Your correlation goes up. All right. I think that's pretty much it. Let's check here on this, make sure we finished everything. So in summary, on number 5, what would that point do to this correlation? What will the correlation do? It will increase. Okay, very good. Let's draw this one in here. Let's see how you did. Original looks something about like that. And then what's this point here going to do to this line? Yeah, it's going to kind of pull up the butt of this line, the back part of it. Because this point, imagine it being a string, and so it's going to kind of pull it up towards it. So it will probably, since it doesn't have high leverage, okay, think about what I just said. It doesn't have high leverage. What gives me the right to say that doesn't have high leverage? Good. Not high leverage because it is not way far out here in the x direction. Okay? So it's not going to be like insanely influential. It's just going to be a little bit. Okay. That's what we got so far. I think I'm going to, let me stop this video here, and then we're going to do one other thing.